gets record. I'm on mute. Do you want to live stream to Facebook?
If that gets you excited, let's do it. Totally up to you.
Cool beans. Give me 2 seconds and we're gonna go live on Facebook.
All right.
I don't know why I'm saying it like that.
If you're just joining us, feel free to grab a piece of paper or pen or pencil and a pencil. We'll be engaging and doing some math together. All right. So, let's see if I can let a few more folks in. Welcome, everyone. My name is Jody Friedman, and you are in our What's Up with Elementary School math session. Today, we are going to be exploring some of the math concepts for students in grades pre-K to 5, and we're going to do some problem solving together. So if you were willing, I would love it if you would put your camera on. As a true teacher, it helps me to see everyone's faces and get a sense of what's confusing or what is working for them. Also understanding if you're multitasking, that's totally okay too. But if you were able to show your faces, that would be awesome, because we will be engaging and doing some online manipulatives. So it would be helpful to see everyone. And I also wanted to just introduce our interpreter, Aldo, who will set us up if you want interpretation.
Buenas tardes, mi nombre es Aldo Reséndiz y yo voy a ser el intérprete para esta noche. Los organizadores del evento de hoy tienen la firme determinación de crear un espacio multilingüe y con esa finalidad contamos con interpretación disponible en español e inglés. Les pedimos a todas las participantes que hablen lentamente y en voz alta y clara en sus micrófonos para facilitar la interpretación. Al terminar este anuncio, activaremos la interpretación para este evento y si usted está usando la aplicación Zoom, podrá ver el icono de un mundo en la parte de abajo de su pantalla. Haga un clic en el mundo para escuchar la interpretación y seleccione español. Si está usando la aplicación Zoom en su teléfono, haga clic en los 3 puntitos donde dice More o Más, elija Language Interpretation y después Español. Si tiene algún problema al hacer esto, por favor escriba un comentario en el chat. Gracias. Hi, good evening, everyone. My name is Aldo Reséndiz, and I'm going to be the interpreter tonight. The organizers of today's event have made a strong commitment to creating a multilingual space. To that end, we have interpretation available in Spanish and English. We ask that all participants speak slowly, loud, and clear into their microphones to make the interpretation easier. Right after this announcement, we will activate interpretation, and if you're using the Zoom application, you will see a globe icon at the bottom of your screen. To listen to interpretation, click on the globe and select English. If you're using Zoom on your phone, click on the 3 little dots where it says More, choose Language Interpretation, and select English. If you have any problems doing this, please comment in the chat box. Thank you.
I'm also providing the link to the PowerPoint in Spanish if you prefer to follow along in Spanish. Great, so welcome everyone. My name is Jody Friedman. I'm the assistant principal at an elementary school in the East Village, and this is my 17th year in schools. I was a 2nd grade teacher, a 4th grade teacher, and a 5th grade teacher. And I'm a math dork, and I really like learning about math and teaching math. But when I went to teach math, I realized that math was very different than how I learned it as a child. And so today we are going to explore math together. I invite you to introduce yourself in the chat by sharing your name and telling us something about yourself using a math problem. So for example, I might say the amount of years I've been in education is 2 times 8 plus 1. Or I might say I moved to New York when I was blank years old, 5 plus 5 plus 5 plus 5 plus 1. So take a moment and just think of any fun fact about yourself that involves numbers, and go ahead and write your name and something about yourself in some type of a math problem. And feel free to chat, type in the chat in English or Spanish, whatever is comfortable for you. I see people have their thinking faces on. So it could be anything. It could be how many children you have. It's a math problem, how many siblings. Awesome. Hi, Wendy. So Wendy has 3 children, so she told about herself using numbers. Anyone else want to introduce themselves using, you could either use numbers or even a math problem. Ooh, so Cindy has a 24 divided by 2-year-old son and a 5 times 2-year-old daughter. Awesome. So 12-year-old and 10. Cool, keep them coming. I think it's always nice to start just realizing that numbers are everywhere in our life. Sometimes when we think about math, we think of math problems, but anytime we're using numbers, we're doing math. So whether it's our zip code or our age or our phone number, or when we're cooking, telling time, trying to figure out what time we need to leave the house to get on the subway to make it to work on time, elapsed time, that is using math. And so we really try to ground math in the real world because math is really valuable and we're using it all the time. But often when we learn it in school, it's very abstract and it's just numbers without a context. And so today we're going to really think about how when we look at math in a context, it really helps our students make sense of it and it makes sense for ourselves. So our community agreements today, we're only here for an hour, which is never enough time, but we encourage you to make space and take space. So we'd love to hear you share and be a part of the conversation. We encourage you to take a risk and be vulnerable. Sometimes doing academic work like math does require taking a risk because maybe it's something that's challenging for you or makes you feel uncomfortable. So go ahead and try it here. We're just here to learn together. What's said here stays here and learned here leaves here. We are going to experience discomfort possibly, and this might be in the way of like, what is she saying? This math looks weird. This is really hard. I encourage you just to stick with it and ask questions. That's the same thing that we ask our students to do. And then if there's anything I say that is confusing, please feel free to ask for a literacy moment. Often as teachers, we use language that is stuff that we don't realize isn't common words. And so if there's any time I say anything that doesn't make sense or someone else, please just ask us to explain ourselves. And so if you just joined us, we were introducing ourselves in the chat using a math problem or numbers. So feel free to continue introducing yourself in the chat if you didn't get to share yet. And lastly, if you're willing to turn your camera on, it is always nice to teach to faces and make human connection. So if you're willing, even if you're cooking or doing anything with your children, it's totally okay. We'd love to see your face. So I wanted to get a chance to understand your experience with math. What was your experience like as a child? Hi, Juana, nice to see your face. And what is your experience like as a parent? So we're going to go ahead and put up a poll. And I would love for you to go ahead and select the answers that best reflect your experience with math. I'll also read it out loud. So for the first question, what was your experience with math as a child? It was your jam, meaning like you really loved math. You passed the class, but you didn't really love it. Or you would describe yourself as not a math person. And then I'd love for you to ask yourself, what has been the biggest challenge supporting your child with math? Is it that the new math is weird and silly? It looks different than when you were a kid. Your child can't do basic or quick math in their head. Maybe your child knows everything in a snap but never wants to show their work, right? Or maybe your child seems confused about all the different aspects of math. So go ahead and select which one best reflects your experience as a student and as a parent with math. I'll give you another few seconds to select your response. All right. So it looks like we have a variety of experiences. For some, we really love math. Others are kind of like, I did it, I passed it, but not really into it. And others are like, I'm definitely not a math person. And then also the experience with our students that for some, it's hard for us to help because the new math is weird and we don't know how to help them. Or maybe their child is struggling with basic math facts or solving quickly. And then often our children don't want to show their thinking. So my goal today is to share some ideas of how to get for us as the adults to get more comfortable with math and understand it so we can help our students. And then also I'm going to share some tools and tricks that might also help you and your student. Let me stop sharing the screen. Poll still showing. Okay. Is the poll showing on your screen or did it go away? Okay.
I just
Got it. Stop sharing. There we go. All right. So together, in our time together, we're going to understand the shift in math practices that came along with the new Common Core Learning Standards. We're going to preview a little bit of what are the expectations for different grade levels. We're going to dig into place value because that is the root of basically all elementary school math. So we're going to learn the difference between a digit, its value, and a number. And we're going to learn how to represent numbers and problem solve a little bit using base 10 blocks. And then I'd also love for you just to type in the chat or unmute yourself. Is there anything specific that you were hoping to learn and explore today that I didn't mention? And feel free to either unmute or just type it in the chat.
Hello. For
Hi.
me, I think it's more like how they use the tape diagrams and stuff like that. Things that I went to school here. I never got to do none of that. Like to
Yep.
connect the adding, and then you gotta do a graph, and then they put numbers in the top, numbers in the bottom, and I'm like, oh, I can help my child with that.
Absolutely. So we'll definitely do some of that. If we don't get to the tape diagram, I'll definitely send out some resource post workshop that also will explain some of the models that we might not get to. But I'll
Okay.
definitely try to model that one for you.
Thank you.
Awesome. And if other things come up, type it in the chat and I'll try to integrate it. And if not, I'll be sure to share some resources afterwards.
Yes, thank you.
You're welcome. So I just want to give you a quick preview. Math, K to 5. Here's what it's supposed to look like. Kindergarten. Our friends are learning how to add and subtract within 5. By the end of kindergarten, they should be able to know 4 plus 1, 2 plus 3. So any of their addition or subtraction within 5. In kindergarten, they should be able to count to 100. And they should be able to represent the number up to 20 using place value. So I'm going to show you a little bit more about place value. And then they're already actually solving word problems in kindergarten. So they're solving problems like there's 3 cats and 2 more come along. How many are there? So adding on. They're solving problems where there's 2 groups. So Jody has 3, Juana has 2. How many do they have all together? And then they're solving takeaway. So Jody has 3, she gave 1 to a friend. How many are left? So that's all by kindergarten. And what we find is when kids are given word problems and things to hold on to act math out, they can actually solve really complex problems because it all makes sense to them. So I've even seen kindergarten where they're working on fractions, because if you give them a candy bar and you tell them to give you half, I guarantee they'll figure out what half is really quick, right? Because they know what equal is and they want to explore. So the idea is that we can explore concepts in the real world. In first grade, students are supposed to add and subtract fluently within 10. They should know their numbers up to 100 and their place values. And now they're solving a little bit more complex word problems. In second grade, they are fluently adding within 10. They're representing numbers up to 1,000 with place value. And then they're adding and subtracting within 1,000. And this is where they start what we used to call borrowing when they subtract, or carrying the one when they're adding. They start that kind of math. And we're going to explain how that's a little bit different now, but that's the concepts. Our third graders, their big thing is multiplication, multiplication, multiplication. So by third grade, we're not really teaching too much addition and subtraction anymore. We're teaching repeated addition, which is what multiplication is. It's adding the same number over and over and over. They're supposed to know their 1-digit multiplication facts. So those numbers that we memorized in the beginning, in the front of our composition notebook. And then they're solving multiplication and division problems. And they're learning the very basics of fractions. So the idea of a half or third, or what is a numerator and a denominator. Oh, Blanca, I see your kids. Thanks for posting that. In fourth grade, they do all of that. And now they're multiplying 2-digit numbers and 3-digit numbers. And they are now adding and subtracting fractions. Right? So now they're taking what they were learning in fractions in third grade, and now they're doing operations with fractions. And then in fifth grade, they do all of those things, but now they're adding, subtracting, multiplying, dividing fractions, decimals, and percentages. Okay? So I just want to give you a kind of quick range of kind of what is the expectation for each grade level before we dig into the math. The Common Core, which is what our math standards are now, brought in a big shift for both educators and students. And this is where we kind of say like, oh, math doesn't look the way that it used to look. And so with the Common Core, they have something called the mathematical practices. And they really believe in emphasizing the habits of a mathematician. So they don't just care about the answer. They want you to prove it. They want you to explain it. They want you to show it in different ways. They want you to model with it. And that is very different than when I was a kid and I got a worksheet that had like 40 math problems on it with no words, just numbers that I just had to procedurally solve. And so what many of us had growing up is what we call procedural understanding of math. We knew the procedure, right? You times the one, you carry the one, you do this thing, but you didn't know why you did it. And so Common Core math really talks about wanting to understand the conceptual understanding. Why are we doing what we're doing? Because you need to know that in order to get a problem in the real world and know what to do. So we don't teach kids to look for keywords. Like when I was a student, I looked at the word all, and they'd be like, oh, that means add. If you see the word all, you always add. But then when we get to multiplication, and you might say, I have 3 containers, and each container has 4 in it. How many do I have in all? That's multiplication, right? And so when we memorize keywords, we're not really understanding what the problem's asking. And so Common Core really talks to us about visualizing what's happening in math. Do you see numbers coming together and getting bigger? Do you see them getting smaller? And using that to think about the operation versus just memorizing words as a signal. So we'll look at some of those together. And the big foundation of all elementary school math is base 10. And that is this idea that our number system is based on tens. And so these are called base 10 blocks. And the idea is that 10 ones equal a 10, which is our tens place. 10 tens, so 10, we call these longs. 10 longs equal 100. So if we had 10 tens, we'd get 100. And 10 hundreds equal 1,000. And so starting in kindergarten and even pre-K, we want students to start representing numbers using base 10s and understanding the different ways they could represent a number. So we're going to try this out together. And I'm going to ask someone to be super brave in a second, and you're going to try to work with our manipulatives to represent numbers. So I first want to give you some background language. When we come to place value, there's a few different words that's helpful to know. So a digit is 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And digits make up every single number that we have. So digits can be put together to create different numbers that represent an amount. right? So the number 5 represents a total of 5, but I also could have the number 52, which represents 52 of something. So the digits are 5 and 2 that make the number 52. And the last thing is that every digit, depending on where it's located, has a value. It's worth a certain amount. So if we look at this example, we have the number 9. 9 can be represented by 9 cubes. So you'll see these 9 cubes here. So the digit 9 represents the number 9, and its value is a total of 9. Now take a look at this number, the number 90. Who can tell me what place value is the 9 in? And you can just unmute yourself or type it in the chat. Where is the 9? What place value is the digit 9? I saw someone put it in the chat. Thanks, Zuli. So Zuli said the 9 is in the tens place. So we have the ones place and the tens place. So this 9 is not, it's the digit 9, but it actually represents 9 tens, right? So you'll see 9 longs here, each one worth 10. So we have 10, 20, 30, 40, 50, 60, 70, 80, and 90. So the digit is a 9. It's in the tens place. So that means I have 9 tens. And so that language is going to be helpful because when we start adding and subtracting with these new models, these numbers need to hold on to their place value. And so I'll give you some examples in a second. So what I would love for us to try, if you have a piece of paper, you can do this on your paper. I'd love you to try to represent the number 2 using the base 10 blocks. How would we represent the number 27 using base 10 blocks? And how would we represent 24? So I'll give you a few seconds to jot that down or just think in your head. Is there someone who would try to annotate on our screen? So to do that, you hover your mouse and at the top where it says you're viewing Jody Friedman's screen, if you click where it says view options, you can scroll and it says annotate. And so if there's someone who'd be willing, can someone underneath the number 2 draw for me how you could represent 2 with base 10 blocks? Zuli, you want to try it out? Okay. So tell us about what you did. Unmute yourself and kind of share what you represented.
Okay. Hi.
Hi.
I just used the 2 as in like the ones. So I
Yep.
just put 2 ones.
Great. And when we use, that's beautiful. And we call them, like when our kids actually have them, they're the cubes,
Yeah.
but they represent the ones place. So she drew 2
My daughter
cubes.
calls them counters.
Perfect. That works too. Can someone try, can someone try making the number 27 for us? They can annotate the screen. Christina, you want to try it out? Not sure yet? Or you're going to try? I just put you on the spot. Sorry. Okay, great. Yep, it's okay. Let's see. It's kind of weird drawing on the screen, so just do the best that you can. Awesome. Christina, do you mind unmuting and explaining how you represented 27? And maybe try to use the word digit and place value in your response if you can.
It's okay in Spanish.
Sure, let's do it.
El palito significa un ten y los otros, Los circulitos serían los ones, que serían, por ejemplo, 2 tens, que serían 20, y 7 ones, que serían 27.
Beautiful. So the 2 you mentioned had a value of 20, right? Because it's not just a 2. The digit 2 is in the tens place, so that's actually 20. So you drew 2 longs and 7 ones. Thank you so much, Christina. And now let's
Okay,
challenge. Thank you. Does someone want to try doing 254 for us? You can unmute yourself if you want to give it a try for us. Okay, someone's going for it. Let's see. Or maybe someone just accidentally drew on it. Anyone want to give it a shot? Or if you don't want to annotate it, just explain how you're thinking about the number 254. Okay, great. Yep. So I see 2 squares, which are our 100 blocks. Thanks, Valerie. Do you want to explain what you drew?
The big boxes represent 100, so it's 200s. The 2 long ones are represented tens. Oh, I missed. I saw 2 instead of a 5.
That's
It
okay.
represents 10, so I was supposed to do 5 instead of 2. And then the small squares are represented by 1, so it's 4.
Beautiful. What I love that you said is you said 200s, 5 tens, which equal 50, and 4 ones. And you did something beautiful that mathematicians do is they explain their thinking and sometimes they revise their thinking. So when you did it, you realized, oh, wait, that was a 5, not a 2.
Yes.
So many of our kids, the mistakes they make, we call them oops mistakes, because it's not that they don't understand. It's just that they maybe rushed through or saw something wrong. And so that's why we always encourage our students to go back and explain your thinking and make sure it matches. So if you find your student doing mistakes like that, you could say, oh, that's called an oops mistake. That's one that you can easily fix because it's not about confusion, right? You understood how to do it. You just made an oops mistake.
Yes.
And so when we explain things out loud or when we explain it to someone else, that helps us solidify what we know. It also helps whoever is the teacher understand where there might be a misconception. So instead of just looking at the answer of a kid who took a test and be like, oh, they got it wrong, they don't get it, they actually might really get it. They just made an oops mistake. Or there's kids who get the answers completely right, but they can't explain it at all, right? And so that makes me know that they might not have conceptual understanding. So we want to be able to do both. Really beautiful job with place value. I am going to clear the screen. If I remember how to do that, give me 1 second. Natasha, do you remember how to clear a screen when people annotate on it? Right. Oh, here, I see it. There we go. Bye-bye, math. We'll come back to you. Okay. So now we understand the basics of place value. And what's also important to remember is we represented these numbers using the most efficient way, right? So when Christina did 27, she did 2 tens and 7 ones. Christina could have also drawn 27 ones, and she would have been absolutely correct because 27 ones and 2 tens and 7 ones are equivalent. They are the same thing. And so we encourage students to represent it in the most efficient way, which is place value, but that doesn't mean it can't be represented in other ways. So similarly with the number 254, we could have said 254 was exactly the way that Valerie drew it. We could have said it's 25 tens and 4 ones. We could have also said it's 254 ones. All of those things are true because there's different ways to represent the number. We encourage kids to do the most efficient because when they start adding, drawing 254 ones can make a lot of space for error to happen and would take a while, but it could still work, okay? Any quick questions about place value? Okay, now we're going to get to the good stuff. So we're going to take our concept of place value and we're going to work on adding and subtracting using place value, which is what the tape diagram that someone mentioned is based off of. And I'm also going to show you how we could continue to use base 10 blocks to do that as well. So when we think about math operations, like I mentioned, when I was younger, we used symbols. So we just saw the plus sign, the minus sign, and numbers, and that's all we were asked to do. But our friends nowadays are given math problems and they have to figure out what to do, right? That's the challenging part. How do you take a word problem and figure out what do you do with these numbers that are there? And so one strategy that's really helpful for students is to ask them to close their eyes, just like they would if they were reading a book, and visualize what's happening in the word problem. So instead of looking for keywords, we ask our kids, what's happening in the story? Are things coming together? Are things getting bigger? Are they getting smaller? So I'm going to say a word problem, and I'd love for someone to just share, like, what do they see happening in their head when this happens? Okay. So I am planning for a wedding, and I have 50 people coming to the wedding, and I have 6 tables, 6 long banquet tables. How many people would I need to put at each table? So who can just in their own words tell me, what do they visualize happening as they hear this story in their brain? What kind of picture are they painting? And feel free just to unmute yourself. And if you were actually solving this problem, like, what might you actually do if you were like trying to figure this out? So besides just like dividing on your own, what picture might you draw? How might you represent this story in your head? Anyone want to share?
Maybe use a multiplication.
Okay. So you would maybe say like, okay, I know I have tables of 6. How many would how many would fit? Or how many, what were you thinking? Tell me more.
Oh, no, no multiplication, division.
Okay. Why are you thinking division?
50 entre 6.
Yep. And so in your mind, you're probably visualizing 6 tables. And in my head, I've got like this 60 people and I'm trying to like see how many people are there. So I'm breaking them into groups. So this idea of breaking into groups is division. Okay. And so when we ask our kids, if it's sometimes we're like, okay, well, what are you supposed to do? It helps them to make a movie in their mind and even draw a picture. I might, if I was a kid or even an adult, I might literally have drawn 6 large tables and start being like 1, 2, 3, and like giving people out. And that's the math model. That's exactly what Common Core wants you to do. So instead of always feeling like you have to use a certain model, a lot of times drawing pictures to solve are the perfect way to model what you're thinking in math. So don't feel like you're stuck using a specific model. So addition, we visualize things coming together or adding on. Subtracting is normally I visualize something being taken away from a group. So I had 5 and I ate 2 cookies, right? So take away. Multiplication is equal groups. So I went to Costco and I bought 6 packages of toilet paper. They came in packs of 18. How many total do I have? I could add 18 over and over because multiplication is repeated addition, or I could do 18 times 6. And then same with division. Division is actually repeated subtraction. So if I had, let's say, 20 slices of pizza and I have 5 friends and I want to know how many slices people can get, I could do 20 divided by 5, or I could do 20 minus 5 because everyone got a slice, minus 5 again because everyone got a slice, minus 5 again because everyone got a slice, minus 5 again, and then I have nothing left and everyone got 4 pieces. So just understanding the relationships between operations and having kids visualize that is super helpful. So now we're going to talk a little bit about addition and subtraction with place value. So if you are anything like me, if you saw this problem when you were a kid, 14 plus 28, you would have done something like 4 plus 8 is 12. I put the 2, I carry the 1. 2 plus 1 is 3, plus 1 is 4. The answer is 42. Thumbs up if that's something like what it would have sounded like if you were to explain that as the way you were taught. Okay, so that's not good enough anymore. The 2 is not a 2, that's actually 20. The 1 is not a 1, that's actually a 10. And so what we did here is we just memorized a procedure to solve math. But what we did not do is show that we understand place value or mathematical thinking. And so I'm going to model for you, and then we're going to try it of how we could actually represent this using base 10 blocks. The algorithm, which is what this is called, would still look the same, but I would explain it differently. So I'm going to put this in the chat, this link. Give me 1 second. You're welcome to go to it later or now. The only issue is if you go to it now, you might not be able to see my whole screen. But this is a very cool math website to represent math problems. So let me just copy and put it here for you. And now I'm going to go to it on my screen and kind of model that for you. Okay. So let's say I wanted to solve this problem. And I already forgot the one that I just told you, but I'm going to do a similar one. Okay, so let me show the number. So let's say I want to do 14 plus, I think, what was it, 28? Is that the one I just said? Okay, 14 plus 28. What I'm first going to do is I'm going to represent my numbers. So I'm going to represent 14. So who can tell me how would I represent 14 using place value? Feel free to unmute yourself.
110 and 4 ones.
So 110. And 4 ones.
Mhm.
And now I'm going to add 28. So how would I represent 28 using place value? Can someone tell me? Isaac, how would I represent 28? Do you know? He's like, oh no, you know I'm here. That's okay. You don't have to share unless you want to. Does someone want to tell us how to represent 28?
Two tens and 8 ones.
Great. So 2 10s. I like them up and down just because that's how my brain works. You could also do this on your paper. So if you want to follow along and just kind of do it on paper, I could very well do it that way too. So now I'm going to do my 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so normally, let's see, well, let me do the numbers. 14 plus 28. So normally we would first add our ones place, and normally we would just say 4 plus 8 equals 12, carry the 1. But we want these to match each other. I was hoping it would let me represent it up and down, but it's not sticking. So first we're going to add our ones place. So we have 4 ones plus 8 ones. We know that 4 ones plus 8 ones equals 12 ones, right? So we would still put our 2 at the bottom like we used to. Is it letting? I don't know why the number's not sticking. Okay. Let me just try one other thing in here. Okay. So we would still have our 12 ones, but instead of carrying the 1, which means nothing, what we're really doing is we're regrouping. So we have 12 ones. 12 ones is the same as 2 ones and 1 10. I'm going to switch tools because I can't represent both things for you right now. So I'm going to do it a different way. That's what teachers do, is know that nothing ever works when you want it to. And I'm going to show it to you this way. Same thing. So if this was my class, I would do this. I'd have them create their 1s and 10s chart. They'd represent the first number, so 14. Bear with my not great clip art drawing. And then 28. 1, 2, 3, 4, 5, 6, 7, 8. Now this is where the modeling makes sense. When our model matches our algorithm. So now I'm going to see if I have a group of 10. So I knew I had 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't have more than one digit in any place value. So what I'm doing is I'm taking this 10 that I have and I'm turning these 10 ones into an additional long, right? Because 12 is 2 ones and 1 10. So I have my 2 ones here. I have my 2 ones here. And now this thing that I used to carry over that meant nothing is actually a regrouping. This is actually 110. It represents what was here. So now I'm going to count my tens place. I have 1, 2, 3, 4. I have 4 tens. So once again, keeping the place value, I have 4 tens. So I have 4 tens, its value, 10, 20, 30, 40. I have 4 tens, which is 40, plus 2 ones. I have 42. So the algorithm stayed the same, but my explanation of what I did changed. Because I didn't just carry a random 1. I didn't just say 2 plus 1 plus 1. I said 2 tens plus 1 10 is 3 tens, plus another 10 is 4 tens, 4 tens, 10, 20, 30, 40. That's what this equals. So we're keeping the place value with the number. For my friends who mentioned the tape diagram, I'm going to do the best I can, or an open number line. It's similar. So the idea is that we use place value to help us. So what we would say is we started with 14. And if I'm adding 28, I'd start with my tens place. And I have 2 tens. It's easy to count by tens in my head. So I'm going to jump 1 10, which is 24. I have 2 tens. So now I need to jump another 10, which is 34. But I'm not done yet because I only added my tens place. I have to add my 8 ones. And so in this model, we're breaking it down by place value. They both represent the same thing, 14 plus 28. Both of them kept the place value. So I wasn't just counting up, I was counting up by place value. And this is where we talked about where efficiency is helpful, right? So my some kids would start at 14 and I would literally see them try to count up 28 ones. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and they'd get lost in their numbers. But when my students get comfortable with their tens, it's a lot easier because my friends also could then say 14 plus 28. As they get fluent, they could start with 28 if they wanted. They could say 28 plus 110 is 38 plus 4 ones. And so when we get good with our place value, we can manipulate these numbers in lots of different ways because they mean the same thing. So now I'm going to show you what that looks like with subtraction, and then I'm going to have you try it out. So subtraction is very similar in that we're going to keep the place value. So once again, when I was a kid, I would have done this. 1 minus 7, I can't do it. So I go next door, I'm going to borrow, right? I think we use the word borrow. I'm going to borrow 10. So the 3 became a 2, and now this becomes an 11, and now I just subtract. So that was the procedure, right? I just said a bunch of numbers. Some kids get really confused, and they might even try to do 7 minus 1, not realizing they can't do that because in subtraction, you only have the first quantity. So I have 31. I'm taking away 17. So in subtraction, I have my friends represent the first number. So I'm going to represent 31. So let's say I have 31 stickers. So I draw my place my place value chart, this represents ones, tens. If I had hundreds, I would do an H for hundreds, but I don't. And I'm going to represent my first number. So 31. I'm going to represent 3 tens. So 1, 10, 2, 10, 3 10. So 10, 20, 30, 31. Now I need to take away 7 ones. Do I have 7 ones to take away? Nope, I only have 1 1, so I can't do anything. So what I need to do is I need to regroup. So I need to play with my place value. Well, lucky for me, I have 3 tens. So now I can take one of these tens and I can regroup it because 1 long is the same as 10 ones. So this 1 10 can now become 10 of these. Excuse my not great drawing. 3, 4, 2 more. So now what I had here before, let me get my little eraser so that this could represent what we were talking about, is 31. I still have 31, but it looks different now because now I took one of my tens. So now I only have 2 tens and I regrouped that 10 and I turned it into 10 ones. And now I have 11 ones. So notice the procedure is the same, but I'm really keeping my place value. So now I can actually start solving my problem. I have 11 ones. I need to take away 7. 1, I'm going to cross them out. 2, 3, 4, 5, 6, 7. I took away 7. I have 4 ones left. Now I have 2 tens left, and I have to take away 1 10. So I'm going to take away 1 10, and I have 1 10 left. So I have 31 minus 17 is 14. So our place value helps us navigate and make sense of this exchanging. I'm trading numbers. Let's say this had been 131. I could have done the same thing. And if I needed to regroup my hundreds, what would my hundreds turn into if I had to regroup? What could I turn my hundreds into? Feel free to unmute yourself. I see you mouthing it, Zuli. Oh, go ahead, Sherry.
90.
Close. Yep. If I have 100, 100 is the same as 10 tens, right? So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I would regroup that way. And so my hundreds would turn into 10. So we're going to try one right now. If everyone has a piece of paper, I want you to try to solve this problem using base 10s. So I'm going to encourage you to first set up your hundreds chart. So you have got your ones, your tens, and your hundreds. I encourage you then to represent your first number. So we have 2 hundreds, 2 tens, and 6 ones. And now I'd love you to go ahead and go through that process of trying to subtract 18 and using your place value language to explain what you're doing to yourself. So go ahead and take a moment and try solving that. When you've solved it, if you could just give me a thumbs up in the camera or in the chat, you can just say done, so I know that you're good on time, and then I'll invite someone to share their thinking with us. Is anyone willing? Remember, being a mathematician is about being brave, and we said we were going to take risks today. Is anyone willing, maybe who hasn't shared, to try to share how they solved the problem or how they used place value to solve this? And you can either annotate, or you could even just turn your camera on and show your paper if that version is better for you. Would love to hear your thinking. If no one's comfortable sharing the whole thing, could someone talk me through the first step? If I was the mathematician, what's the first thing I would do? And you can explain to me and I can kind of model for you here. What's the first thing I would do? Blanca, do you want to share? Okay. I heard someone unmute themselves. Go for it. Oh, hi. Great.
Sí, al parecer por lo poquito que vi cuando desglosó la decena, creo que sería algo parecido, que tendría que ocupar 2 decenas y desglosar una, pero la duda me quedaría dónde voy a poner los otros 2 que me quedarían, ¿no?
Aldo, do you want to translate for me? Is he still here? Oh, he's on the other, so he can't translate. Okay. Thank you so much for sharing. We would start in our ones place. Blanca, did you want to add on or try also?
Yes, the 6 is borrow the 2, borrow 1 to 6 to take 8, out, and later leave 1 and minus 1, 0.
Great, so let's try it. So she said that, I'm going to stop for 1 second just so I can catch up with what you had. So we're going to take 1 10 and turn it into 10 ones because we didn't have enough, right? We couldn't take the 8 from the 6. So now we can take our 8 away.
Yeah. And the next one is lead 1 and take 1 out. It's
Great.
6.
So we had 2 10s. Now we only have 1 10 left, and we're taking that 1 10 away.
Yeah.
So we're left with 0.
Yeah. And later I had 2, and it's to the
Beautiful.
down.
So 2 hundreds, right? This is our hundreds place. So 2 hundreds, take away 0 hundreds. We're left with 2. If you were my student, I'd say kiss your brain. Good job. That was really hard. And so I just wanted to show you how once we understand what's happening with math, when we can have our kids represent it, then this process starts to make a lot more sense. And it's not just random numbers, it's keeping with place value. So we never have enough time. There is so many more slides that I had that we will not get to, but that is totally okay. I will share some resources with you for some of the other content that we didn't get to today. What I did want to share, let me just share my other screen with you as we wrap up for today. Here we go. Is that in general, we want to make sure that our students understand their math. And when kids have word problems and can draw pictures to help them solve, it helps a lot more. So even if kids have to physically draw the pictures, if there's 5 bunnies and I take 3 away and kids sketch 5 bunnies, that's the same as drawing 5 cubes. They're just not yet at cubes, they're drawing bunnies, and that's okay. And eventually we teach them just to draw cubes instead of bunnies. So these representational drawings. So this website is a really great one. As your kids get older, place value stays important when we get to multiplication. So if you have some of those older grade friends, this is probably what they're starting to do. And I'll send a video where it explains how place value lives within multiplication, just like it did within addition and subtraction. So once again, we're not going to just do the standard where we did 6 times 3 is 18, put the 8, carry the 1, 4 times 3 is 12, add the 1, carry this. We're actually going to keep place value as part of the conversation. And so as we wrap up for today, what I would love you to do is, if you're willing, what's one aha moment that you had during our math session today? Or what's one thing that you're excited to try with your child? And you can feel free to unmute yourself or to type it in the chat.
Hi.
Hi.
I didn't realize how much of the way I learned math was formulaic and not necessarily like helping me expand my thinking, as opposed to like this kind of math is more visual. So it helps me like process things, and it doesn't only translate to math, but it can translate into like other forms of thinking for other subjects as well. I didn't realize how to the book, I don't know if it's to the book, but like how, or like you said, procedural. I didn't realize how procedural everything I learned in school was. It wasn't about using creativity, and this is more about using creativity, which I think is good because my child is like she's a visual person. So yeah.
Thank you. And I think that the part about the Common Core, about the new math that is great, is it is so visual, right? Like kids were saying, draw pictures to help you solve it. That's perfect.
Exactly.
And that's going to help you make sense of the problem. So thank you so much for sharing. Can I have one other share? And then thank you. I learned about the ones, tens, and hundreds place. Any other share?
I think that once again, seeing the visual representation is really very helpful. So just to undergird or repeat what has already been said, but it really, really does help me see what actually is happening, so I have a deeper understanding.
Awesome. Thank you. And like I said, I'll send some links for some of the higher level math just to help explain what that looks like. But I think especially for students with IEPs, for any students struggling with math, representing their thinking is going to be a huge help. And some classrooms have actual cubes and longs where they can physically regroup them and take a 10 stick and turn them into 10 ones. And then when they're ready, they can transfer it into the picture. So that then when they just do the algorithm, they can still do the algorithm, but it conceptually makes sense and they can explain it using place value. So I just want to thank everyone so much for being here today and for taking time out of your evening to flex your brain, your math brain muscles. We have some awesome other workshops with Liberation School coming up. So there's one on culture responsive texts. And so keep your eyes open for some of the really great programming coming out of this opportunity with Liberation Schools. And I will, in the follow-up email, include my contact information. So if any specific questions come up, please don't hesitate to reach out. Thank you and have a great night.
Thank you.
Thank you. Good night.
Good night.
Thank you.
Good night.
Good night.
Thank you.